Welcome to the deep dive. We're back, and this time we're exploring something that's really shaking things up for software developers, AI-powered testing.
That's right.
You might remember we touched on AI for code generation, even debugging in past deep dives. This feels like the next logical piece of the puzzle.
Exactly. It's about how AI is fundamentally reshaping, really critical part of the whole software lifecycle.
Right.
So the core question for us today is really understanding how AI is transforming testing. And maybe more importantly, what does this mean for you? Whether you're deep in the code every day or just interested in where tech is heading.
Yeah, and I think everyone who's ever written code can relate to those frustrations, right? The late night bug hunts that seem to go on forever.
Oh, yeah.
Or just the sheer slog of manually writing test case after test case. AI is starting to offer some, well, pretty compelling answers here.
It really is. We're talking about tools that can, generate tests on their own, dig deep into your code to find weaknesses you might miss.
And even predict where things might break. That sounds huge.
It is, and the scope is pretty broad. Let's maybe start with the basics, unit testing.
Okay.
So traditionally, that's developers writing very specific bits of code to check if individual functions or modules work as expected.
Right, the building blocks. It's fundamental, but wow, can it eat up development time?
It absolutely can. And this is where AI is making some, really significant inroads, automating the creation of these unit tests.
So imagine an AI tool just looking at your code and poof, generating the tests.
Pretty much. It examines the code, understands the logic, and creates tests to validate it. This frees up developers, allows them to focus their energy on, say, more complex integration challenges or higher-level strategy.
Less repetitive work.
Exactly. And the upside isn't just saving time, though that's a big one.
Okay.
You potentially get much better test coverage. These AI tools can be quite good at finding and testing edge cases.
Those tricky scenarios a human might overlook.
Precisely. The things you don't immediately think of. This leads to, more robust code at the unit level. We're already seeing tools like Diff Blue Cover, GitHub Copilot even, starting to integrate these kinds of features.
Interesting. Okay, so that's unit testing. Let's zoom out a bit. Integration testing.
Right. So here, the focus shifts. It's not just about individual pieces, but how different parts of your system actually work together.
Making sure the gears mesh properly.
Exactly. And this gets really tricky in complex systems. Think about microservices architectures.
Oh, yeah, lots of moving parts.
Loads of independent services talking to each other.
Yeah.
Understanding and testing all those interactions. That's a major challenge.
So how does AI help there?
Well, it can analyze how these different components communicate, sniff out potential points of conflict or misunderstanding between them, and then generate very targeted test scenarios specifically designed to probe those interactions.
So instead of testing everything broadly, it focuses on the critical connection points.
Kind of, yes. It helps prioritize and target the testing effort where it's most needed, the real-world impact. It can mean a huge reduction in the time and, frankly, the headache involved in integration testing.
I can see that being incredibly valuable.
It leads to more efficient testing and, ultimately, a more stable system overall.
Okay, now for something I suspect many developers have a love-hate relationship with. UI testing.
Ah, yes.
I mean, manually clicking through screens, checking every button, every form.
It's necessary, no doubt, but wow, is it tedious and prone to human error, especially when UIs change frequently.
So AI steps in here too.
Definitely. Automation of UI testing is a big area. AI tools can basically simulate a user clicking, typing, scrolling, navigating menus, all automatically.
Okay, simulating clicks is one thing, but what are the real benefits beyond just speed?
Well, several things. First, obviously, catching UI-specific bugs, visual glitches, elements not working, weird layouts.
Right.
Second, spotting inconsistencies. Does this button look the same here as it does on another screen? That kind of thing.
Design consistency, okay.
And third, uncovering performance issues. Maybe a specific interaction makes the app hang or slow down. AI can simulate that repeatedly.
And you mentioned specific tools.
Yeah, there are leaders like Apple Tools and Testim.io, and they're doing something really clever called Visual AI.
Visual AI, what's that about?
It's pretty cool. Instead of just checking if an element exists, these tools take screenshots and compare them to a baseline, like a known good version. But they do it intelligently.
How so? Not just pixel by pixel.
Not just pixel by pixel. Visual AI is trained to understand the visual meaning. It can tell the difference between, say, dynamic content changing slightly, which is fine,
Right.
and a button suddenly being half off the screen, which is definitely not fine.
So it understands context, not just raw pixels.
Exactly. It
Yeah.
catches subtle visual regressions as simple automation, or even a person glancing quickly might miss. It's about ensuring the user experience looks right, not just functions.
That really does sound like a leap for anyone working on front end. Okay, let's shift gears slightly. Code coverage analysis. We've had tools for ages that tell you, your tests cover 70% of your code.
Yeah, that percentage. It's a useful metric, a starting point, but it doesn't tell the whole story, does it?
No, you could cover 90% but miss the most critical, complex part.
Precisely. And that's where AI is adding more depth. It's not just how much code is covered, but how well it's covered. AI can analyze which texts are hitting which parts of the code and identify gaps in potentially vulnerable or complex areas.
So it's smarter coverage analysis. It can say, hey, you've got tests here, but maybe not the right tests for this tricky bit of logic.
Exactly. It can pinpoint those gaps and even suggest specific kinds of tests you should probably write to cover that critical path or that complex algorithm more effectively. It helps you focus your efforts.
More proactive vulnerability finding, in a way.
You could put it like that, yeah, leading to a more robust and secure application.
Okay, this is all super useful for finding existing problems, but earlier you mentioned something that really caught my ear, predicting failure points. That
Yeah.
sounds, well, futuristic.
It does feel a bit like that, but it's a very real and exciting area of development.
How does it even work?
Well, it's about pattern recognition, mainly. AI can analyze historical data looking at code patterns, like certain complex structures or styles that have frequently led to bugs in the past.
Okay.
It combines that with historical bug report data, maybe even anonymized user behavior patterns that correlate with failures. By crunching all this data, it can start to predict which areas of your current code base are statistically more likely to break down in the future.
So it's like, warning, this module looks statistically similar to ones that caused major headaches last year.
Kind of, yeah.
Yeah.
It's important to stress, though, these aren't crystal balls.
Right, not guarantees.
Exactly. They flag potential risks based on patterns and history. It allows you to be proactive, maybe add extra testing or scrutiny there, but it doesn't replace thorough testing.
Still, moving from just reacting to bugs after they happen to proactively looking for weak spots, that's a big shift.
It's potentially a massive shift. Think of the debugging time saved. It moves us towards prevention, leading to, hopefully, much more stable software right out of the gate.
This all sounds incredibly powerful, but there have to be some catches, right? Challenges, limitations.
Oh, absolutely. It's not all smooth sailing. One big one is the black box problem you sometimes get with AI.
Meaning you don't know why it made a decision.
Exactly. Why did the AI generate this specific test case? Or why did it flag this particular piece of code as risky? If you can't understand the reasoning, it's hard for developers to fully trust the tool or know how best to act on its output.
So transparency is key. You need explainability.
Totally. Developers need to be able to see the why, to build confidence, and use these tools effectively. If it just spits out results without context, it's much less useful.
Makes sense. What else?
Well, like most AI, it's hungry for data. These tools need massive data sets, code, big reports, test results to train effectively. So, if you're working in a very niche domain or with cutting-edge technology where there just isn't much historical data available yet,
The AI might not be as effective.
its accuracy and usefulness could be limited, yeah. The quality and quantity of training data are pretty crucial.
Okay, data dependency and the black box issue. Got it. Now, you mentioned something earlier that sounded almost like science fiction self-healing tests. Can we dig into that a bit?
Yeah, this is a really fascinating space, still quite new, but with huge potential. The core idea is tests that can adapt automatically when the code they're testing changes.
Adapt how?
So let's say you refactor some code, maybe rename a function or change an ID on a button in the UI.
Okay, normally that breaks your existing tests, right? You have to go fix them.
Exactly. A self-healing test, theoretically, could recognize that change. Maybe it sees the function signature change slightly or the button's text is the same, but the ID is new and it adjusts itself to keep working. It heals itself, essentially.
Wow, so you rename a button, and the test just figures it out and keeps testing the new button.
That's the goal. Imagine the impact on test maintenance.
Huge. Maintaining test suites as code evolves is a constant task.
It really is. Self-healing tests could massively streamline that, keeping your tests relevant and effective with much less manual effort as the application changes over time. It's still early days, but the potential is definitely there.
Okay, let's try and make this more concrete. Can you walk through a practical example? Maybe that e-commerce app again?
Sure. So imagine an